Hello viewers, this is Wagadara now taking you through the tutorial for A-Level Applied Mathematics. And this video, we're going to look at the topic of motion of connected particles involving inclined planes. So this video is for under mechanics and is suitable for students in both senior 5 and senior 6. Now these are the very questions I left in the previous video, and I believe by now you've already tried them out and ready to mark yourself and check your progress. So shall start with question 1. So question 1 says, in the figure below, a particle A of mass 7 kilograms rests on a rough plane of inclination theta to the horizontal, where theta is equal to arctan of 3/4, and with coefficient of friction 0.6. Particle A is connected to particle B of mass 3 kilograms hanging freely by means of a light inextensible string passing over a smooth fixed pulley at the bottom of the inclined as shown. So in this case they have helped us by drawing the sketch diagram, but in most cases the diagram will not be drawn, and it will be you to read the question, interpret it, and be able to come up with your own sketch which should be correct. So here they say that if the system is released from rest so that A slides downwards, find the Roman 1 acceleration of the system and the tension in the string, then Roman 2 force on the pulley, and Roman 3 velocity of the 3 kilogram mass after 2 seconds. So we know that this is the information given. Coefficient of friction is 0.6 and the inclination is 3/4, meaning that theta is 36.8699 degrees. Therefore, the first thing to do is to redraw the given sketch so that you can first show the forces acting on the particles. So that the sketch which was given, next is to show the forces. Like we always say, the first step is to show the weight. So for this, it will be 7g because it was 7 kilograms, so the weight will be 7g, where g is acceleration due to gravity. So this g is not grams, it is acceleration due to gravity. Then we shall show the components of this weight. So the component parallel to the plane will be 7g sine 36.8699 degrees, and the component perpendicular to the plane will be 7g cos 36.8699 degrees. So note that these components are represented by dotted lines. The components are represented by dotted lines, so always note that. So because of this, there will be a normal reaction, and that will be capital R. Then for this mass, weight will be 3g, and it's acting downwards, meaning that here tension will act upwards, and to be capital T. So in this case, it is one string connecting both particles, meaning the tension is the same throughout the string. So that means that even here, because this was upwards, here to be downwards and to also be T, and this will be upwards and to also be T, here to be downwards and to also be T. Then they told us that the particle, this one moves downwards, so this will be the direction of motion will be represented by acceleration. So this one goes downwards and vertically downwards, and also this one moves down the plane. So they both have the same acceleration. Now because this one is moving downwards and this plane is rough, it means that friction must oppose motion, meaning that it has to move be in the direction of must be in the upward direction. So we shall come and show our friction there, and to be mu r, where mu is 0.6 and r is this normal reaction. So before we go to the next slide, the mark B1 will be for correct force diagram, and force diagrams are drawn using a ruler. So now I shall use that diagram to answer these questions. So part Roman 1, they ask for the acceleration of the system and the tension of the string. Roman 2, they ask for the force on the pulley. Roman 3, they ask for the velocity of the 3 kilogram mass after 2 seconds. So for the 7 kilogram mass, you come here. So for this 7 kilogram mass, we are interested in this. So parallel to the plane, perpendicular, first of all, perpendicular to the plane, we are interested in this, meaning that capital R will be equal to 7g cos 36.8699 degrees. Then parallel to the plane, we are interested in these forces, these ones, and that acceleration. So that means that downwards it will be 7g sine 36.8699 plus capital T minus mu r is equal to ma, where m is 7 kilograms. So here we shall come and say that for the 7 kilogram mass, resolving perpendicular to the plane, we shall come up with r is equal to 7g cos 36.8699 degrees. But we know that g is 9.8, so we shall substitute for g and substitute for cos that. Cos that is the same as 4 over 5. So in the end, we shall come up with our r being equal to 54.88 newtons. So that was resolving perpendicular to the plane. What about resolving parallel to the plane? So just like we already saw, when I resolve parallel to the plane, I'll come up with t plus 7g sine 36.8699 degrees minus mu r equal to 7a. So now that I've got r and I know g, I can come and substitute. And I also know mu was 0.6, so I'll come and substitute for those values to come up with that. So I think we realize that we have two unknowns here. So next is to simplify. When I simplify, I'll come up with that, and that will be my equation 1 with two unknowns. So the second equation will be got from the 3 kilogram mass. So we shall go back to our diagram and say that for the 3 kilogram mass, we are interested in these forces. So these forces, the motion is downwards, meaning that the resultant force will be 3g minus t equal to 3a. So you come here and say that for the 3 kilogram mass, 3g minus t is equal to 3a. So I know g is 9.8. Therefore, I come up with an equation 2, which is 29.4 minus t equal to 3a. So I have two equations and two unknowns. Next is to solve them simultaneously. So when I say equation 1 plus equation 2, this is what I'm going to get. So this was equation 1 and this is equation 2. And when I add the 2, you realize that this t and this t cancels. Then this plus this gives me that. Then this plus this gives me that. So in this case, I have only one unknown, which is a. Next is to make a the subject. Therefore, when I divide both sides by 10, I'll come up with a being equal to 3.7632 meters per second squared. So that was the acceleration. Now what about from equation 2? When I come to equation 2, I'll be able to get my tension. So I'll come and say that 29.4 minus t is equal to 3 times acceleration, which is that. In that case, I have only one unknown, which is t. Therefore, when I make t the subject, t will be 18.1104 newtons. So that was Roman 1. They wanted acceleration and tension in the string. So basically, that was Roman 1. Now let's see how marks can be awarded. So B1 for normal reaction, B1 for equation 1, B1 for equation 2, M1 for addition, A1 for acceleration, M1 for substitution, A1 for tension. So that was Roman 1. Roman 2, they wanted the force on the pulley, so force on this pulley. And Roman 3, they wanted velocity of the 3 kilogram mass after 2 seconds. So for this force, for this pulley, we are interested in these forces here. So these two force tensions will cause a normal reaction here. A reaction at that point, which is in that direction. So it bisects these two forces. So we shall come here and first draw the forces. The good thing, we know the value of T is 18.1104. So we shall come here and say that for part Roman 2, those will be the forces acting. I think realize that this was the tension in the string. These are the two tensions in the string. They must, so this reaction or force on the pulley will pass through the bisector of these two forces. I think realize that this angle and this angle are equal, and I've called them beta because I don't know them yet. So we are told that the inclination is 36.8699. That's why you see here this being equal to 36.8699. Then another thing, we know that this is horizontal and this is vertical, meaning that from here up to here will be 90 degrees. That's why there's this symbol to mean right angle. So with that, we can be able to get our beta, because we know that from here up to here is equal to 2 beta, but also it is equal to 36.8699 plus 90 degrees. So we shall come here and say that 2 beta is equal to 90 plus 36.8699. Therefore, beta is 63.43495 degrees. So now that we have got beta, we can now go ahead and resolve. The easiest way is to resolve along this line of action. Therefore, I think we realize that this force, the angle beta, lies on that line of action, and also this beta lies on that line of action, meaning that when I resolve along this, I'll come up with T cos beta here plus T cos beta here, which will be equal to R. So this, I think we realize that R was already used. So in this very question, to mean normal reaction of the 7 kilogram mass, meaning that here we have to change. So let's use RP. So when you use RP, we shall come up with RP being equal to 2T cos beta. Now the good thing, I know T in the previous part and I also know beta, so I come and substitute to come up with RP being equal to 2 times T, which is 18.1104 cos beta, which is 63.43495 degrees. So next is use the calculator to come up with RP being equal to 16.1984 newtons. So the force on the pulley is 16.1984 newtons, inclined at 63.43495 degrees to the vertical. Remember, force is a vector quantity, so it has both magnitude and direction. That's why you don't only stop at magnitude, you also set the direction. So now we shall go to part C, or Roman 3. So Roman 3 says, Roman 3, they wanted the velocity after 2 seconds of the 3 kilogram mass. Therefore, we shall use the first equation of motion. We know the initial velocity because it was initially at rest. Therefore, this will be 0. Acceleration, we already got it in Roman 1, which is that. And time, they give it to us in the question, which is that. So when I use the calculator, I'll come up with my value of V as 7.5264 meters per second. So basically, that's what they wanted, and now let's see how mass can be awarded. So M1 for resolving, A1 for reaction, and M1 for this, A1 for that. So now we shall go to question 2, which came from UNEB 2015 paper 2 question 11, and says the diagram below shows a 12 kilogram mass on a horizontal rough plane. The 6 kilogram mass and 4 kilogram masses are on rough planes inclined at 60 degrees and 30 degrees to the horizontal. So this is 60, this is 30, this is 6 kilogram, 4 kilogram there. The masses are connected to each other by light inextensible strings passing over smooth pulleys A and B. So this is pulley A and this is pulley B. So here they say that the planes are equally rough. Equally rough means that the coefficient of friction is the same. So equally rough with the coefficient of friction 1/12. If the system is released from rest, find part A, the acceleration of the system, and part B, the tensions in the strings. So in this case, the first thing to do is to make a sketch is to first redraw the sketch which was given in the question. So let's redraw the sketch. Remember, this first diagram is drawn using a ruler. Okay, so that is a sketch which was given. Next is to now show the forces acting on each particle. Remember, like we have already said, the first force to show is the weight. So let's start with this one. The weight has to act vertically downwards to a 6 kilograms, so the weight will be 6g, where g is acceleration due to gravity. Because it's on an inclined plane, there will be two components. So one will be component part of the plane, and that will be 6g sine 60 degrees. The component perpendicular to the plane will be 6g cos 60 degrees. So because of this, there will be a normal reaction which will be R1. So that is for this mass. What about for this mass? For this mass, we shall also start with the weight. So the weight will be 12g because it was 12 kilograms. Then because of this weight, there will also be normal reaction here, which will be R2. So that is that mass. What about this mass? So that mass, we also start with the weight, which will be 4g, and because it's on an inclined plane, there will be two components. So one will be component part of the plane, and that will be 4g sine 30 degrees, and the component perpendicular to the plane will be 4g cos 30 degrees. Because of this, there will also be a normal reaction which will be R3. So we have shown weights and normal reactions. So next is to show the tensions in the strings. So what you should realize is that now these are two different strings. So from here to here it is one string, and from here to here it is another string. What does that mean? It means that from here to here there will be one tension, and from here to here it will also be another tension. So if from here to here the tension is T1, then from here to here the tension has to be T2. So let's do that. So to show that, to know the direction, look at this component part of the plane. It is acting down the plane, so here the tension will be up the plane, and that will be T1. Here to be, because this is up the plane, here to be down the plane, and that will be T2. Then here to be to the right, that will be T1, T1 still. So all is T1, sorry, all is T1. So here to also be to the left, and that will be T1. That is for this side. Now for this side, we shall also look at this. So this is down the plane, so here to be T2 up the plane, here T2 down the plane, here T2 to the left, and T2 to the right. So those are now the tensions. Now next is to show the acceleration. So for you to know to show the accelerations, you have to compare this with this. You realize that this component is heavier than this, or is bigger than that. So what does that mean? It means that this will go down the plane, and this will go up the plane, and this will go to the left, just as it is here in this simulation. So So this is how the motions will be. This will be down the plane, this will be to the left, and this will be up the plane. So let's show those accelerations. But remember, these planes are also rough, meaning that there will also be friction. So for this 6 kilogram mass, acceleration will be down the plane, and that is it. So acceleration is the same throughout. Now because this is down the plane and friction opposes motion, meaning that friction must be up the plane, so that's here we shall come and put mu r1, which will be up the plane. What about for the 12 kilogram mass? 12 kilogram mass, it will be to the left, and because it is to the left, meaning friction will be to the right, so we shall come and put friction to the right, which will be mu r2. So that is for the 12 kilogram mass. What about for the 4 kilogram mass? For the 4 kilogram mass, acceleration is up the plane, and because it is up the plane, friction must be down the plane. So we shall come here and put friction down the plane, which will be mu r3. So basically that is our correct force diagram. Remember, it must be drawn using a ruler. So drawing all that using a ruler, that is B1. So I should use this force diagram to answer the questions which were asked. So the questions which were asked was part A, acceleration of the system, and part B, the tensions in the string. So they want the value of this A, and also the value of T1 and the value of T2. So we shall start with the 6 kilogram mass. So if you look at the 6 kilogram mass, in this case, perpendicular to the plane, R1 will be equal to 6g cos 60 degrees, but parallel to the plane, you realize that this A is down on the plane, so we are interested in these forces. These are the forces we are interested in, and also this acceleration. So this acceleration is facing downwards, meaning that this is bigger, so it will be 6g sine 60 minus T1 plus mu r1, that as the resultant force, and to be equal to ma, where m is 6, so it will be 6a. So you come and write down that equation here. So know that 6g sine 60 is minus open brackets T1 plus mu r1 is equal to 6a. So the good thing, we know that r1 is equal to 6g cos 60, and we know that mu is 1 over 12, it was given in the question, and we know that sine 60 is root 3 over 2, so root 3 over 2 times 6 will be 3 root 3, that's where this 3 root 3 is coming from. This g is that g. So when you open brackets and simplify, we shall come up with 3 root 3g minus T1 minus 0.25g is equal to 6a. So that is equation 1. So next will be the 12 kilogram mass. So when you look at this 12 kilogram mass, vertically upwards, vertically we are interested in these two forces. Therefore, what does that mean? It means that R2 is equal to 12g. What about horizontally? Horizontally, we are interested in these forces, and the acceleration is moving in that direction, meaning that T1 is bigger than these two. Therefore, the resultant force will be T1 minus open brackets T2 plus mu R2 equal to ma. So you are coming and write that T1 minus open brackets T2 plus mu R2 is equal to 12a, where 12 is the mass. Therefore, we know mu, we know R2, we already saw that R2 is equal to 12g, so we shall substitute for R2. Mu is already given in the question as 1 over 12. So when I simplify, I'll come up with T1 minus T2 minus g equal to 12a as my equation 2. Then next we shall go to the 4 kilogram mass. So when you go to the 4 kilogram mass, so perpendicular to the plane, we are interested in these two forces. What does that mean? It means that R3 is equal to 4G cos 30 degrees. What about parallel to the plane? Parallel to the plane, we are interested in these forces here and also this acceleration. So acceleration is upwards, meaning that this T2 is bigger than these two forces. Therefore, the resultant force will be T2 minus, open brackets, 4G sin 30 degrees plus mu R3. So you come here and say that for the 4 kilogram mass, T2 minus, open brackets, 4G sin 30 degrees plus mu R3 is equal to MA, which is 4A. So the good thing, I know R3 is 4G cos 30 degrees and mu is 1 over 12. Therefore, I come and substitute and also simplify further. So before we go to the next slide, let's see how mass can be awarded for this slide. So this for resolving and this for B1 for simplifying. B1 for this and this one for resolving. So for the next slide, we shall simplify this equation. So when I simplify, that is what I'm going to get. And when I simplify further by removing the LCM, LCM is removed by multiplying throughout by 6 to come up with 62 minus 12G minus root 3G equal to 24A. So I have 3 equations and 3 unknowns. The unknowns are T1, T2, and A. Therefore, the next thing to do is to solve them simultaneously. So I'll begin with equation 1 plus equation 2. So when I add equation 1 to equation 2, this is what I'm going to get. So this was equation 1, this was equation 2. Now I'm going to add. And when I add, you realize that this T1 can cancel. So I remain with root 3G, which is there. Then this one, negative 0.5 plus negative G, 0.25G plus negative G will give me negative 1.25G. Then this negative T2 will give me this negative T2 here. Then this 6A plus 12A will give me 18A here. So I'll call that equation 4. Then next is equation 3 multiplied by 6 times equation 4. Remember, my aim is to first eliminate the tensions. So when I do that, this is what I'm going to get. So this is equation 3, this is equation 4 multiplied by 6. So when I multiply 6 throughout this equation, this is what I'm going to get. Now in that, I want to add the 2 equations. So when I add, you realize that I've managed to eliminate the tension. So this T2 has cancelled. So this 18 root 3G minus root 3G will give me 17 root 3G. Then negative 12G plus negative 7.5G will give me negative 19.5G here. Then 24A plus 108A will give me 132A. So I've managed to eliminate all the tensions, and I only have A as the only unknown. Remember, G is 9.8. So what I'm going to do, I'm going to substitute for G and remain with A as an unknown. Therefore, when I make A the subject, I'll come up with A equal to 0.7383 meters per second squared. So I managed to get the acceleration. So before I get the next slide, let's see how mass can be awarded for this. So B1 will be for equation 3, M1 for this addition, and A1 for this acceleration. So now that I've got acceleration, I can use the end of the equations 1, 2, 3 to come up with the values of T1 and T2. So from equation 1, This is what I have, so I've substituted for the value of A and also for the G, and I'll have only T1 as the only unknown. So when I simplify, I'll come up with T equal to 44.0425 newtons. Then from equation 2, I'll come up with that. So this is T1, I've substituted for T1, I substituted for G and for A, so I have only T2 as the only unknown. Therefore, when I make T2 the subject, I'll come up with T2 being equal to 25.3829 newtons. So basically, that's what they wanted. Now let's see how mass can be awarded. So M1 for the substitution, A1 for output, M1 for substitution, A1 for output. So that was question 2. Now we shall go to question 3, and question 3 was got from UNEB of November 1998, paper 2, question 13, and says, to one end of a light inelastic string is attached a mass of 1 kilogram which rests on a smooth wedge of inclination 30 degrees. The string passes over a smooth fixed pulley at the edge of the wedge under a second smooth movable pulley, not this word movable pulley, of mass 2 kilograms, and over a third fixed pulley, not that word fixed pulley, and has a mass of 2 kilograms attached to the other end. Find the accelerations of the masses and the movable pulley and the tension in the string. Assume that the portions of the string lie in a vertical plane. So this is what I've been telling you in the previous questions. They have been drawing for us the sketch, but like I said, sometimes they may not draw for you the sketch, and it is you to read the question, interpret it, and come up with a correct sketch. So in this question 3, unlike the question 1 and question 2, they have only given us the words, and you have to read the question and come up with our own sketch, and the sketch has to be correct. So let's see how we can do that. So the first thing to do is to come up with a correct sketch. So first of all, they gave us an incline of 30 degrees, and they gave us this fixed pulley here up the incline, and also this fixed pulley to a fixed position, and also this movable pulley. So that will be the arrangement. So there was a mass hanging after this fixed pulley, and also a mass hanging after this fixed pulley, and this movable pulley was hanging vertically. So the next thing to do, so that is the sketch. The next thing to do is to show the forces acting. So like we have always done, the first force to show is the weight. So for this mass, 1 kilogram mass, the weight will be 1g, and because it is lying on an inclined plane, there will be 2 components. So one will be parallel to the plane, and that will be g sine 30, and another one will be perpendicular to the plane, and that will be g cos 30. Because of this, there will be normal reaction here, and that will be capital R. Then because of this one, the tension here will be upward. So this is down the plane, this will be up the plane, and because this is up the plane, here it will be down the plane. So one thing you should realize is that this is one string throughout. So from here through this, through this, through this, through this, it is still one string. That is, and that means that the tension is the same throughout. That is why we are using T throughout. So for this one, the weight will be downwards, and because it is downwards, here tension will be upwards. So this will be upwards, and also here upwards. Then because this is upwards, here it will be downwards, and also here downwards. Then for this one, weight will be downwards, and it will be 2g, and because this is downwards, here tension will be upwards, and here tension will be downwards. So you have shown the forces. Next is to show the accelerations. So for you to show the accelerations, you have to compare this with this. So sorry, this and this, add these two, then compare them with this. Now if you compare, you realize that when I add this with this, it will be bigger than this one. What does that mean? It means that as on this diagram, you will show that this will go downwards and also this will go downwards while this will go upwards, just as it is here in this simulation. So I think realize that this one is moving downwards, as you can see it here, and this one is moving upwards, as you can see it here, and this one is moving downwards, as you can see it there. So that is so we already saw this in the previous topics under pulley systems. So if you have some issues, you can go back and refer to those previous videos we made so that you can know how to answer such questions. So now that you have known that, next let's show the acceleration. So this will be downwards and it will be A1, then this will also be downwards and it will be A2. Now this one will be the average of these two accelerations, this and this. The average of those two will be the acceleration for this movable pulley. Okay. So now that you have shown the accelerations and the forces, you shall go and start resolving. So for the 1 kilogram mass, resolving parallel will be this. We shall need these forces. So, and this acceleration, I think we realize that it's going downwards, therefore this is bigger than this, therefore that and force will be G sine 30 minus T equal to MA, where M is 1 kilogram, that's why it is 1 times A1, that's why you see here just A1. So sine 30 is 0.5, so I come and substitute for sine 30, and that will be equation 1. What about for the 2 kilogram mass? For the 2 kilogram mass, we are interested in these forces and that acceleration. So it is moving downwards, meaning the resultant force will be 2G minus T equal to 2A2. So we shall come and write that as our equation 2. The next will be for the movable pulley. For the movable pulley, we are interested in this. So this is moving upwards, meaning the resultant force will be the sum of these two forces, which will be 2T minus this, which is 2G equal to MA, so equal to 2 times this acceleration. So we shall come and write that here. The next we shall simplify this cancels to come up with that as our equation 3. So we have managed to get 3 equations and 3 unknowns. So the unknowns are T, A1 and A2. Now because we have 3 equations and 3 unknowns, it means that we can solve simultaneously. Now before we go to the next slide, let's see how much can be awarded for this slide. So B1 for the correct first diagram drawn using a ruler, B1 for equation 1, B1 for equation 2, B1 for equation 3. So what we are going to do, we are going to multiply 2 throughout equation 1 and add it to equation 3, and when you do that, this is what we are going to get. So here we have multiplied equation 1 by 2 and this is equation 3, so we are going to add these 2 equations. So when you add, you realize that this 2t and this 2t cancels, and this minus this gives you negative g, then this plus this gives you 3a1, and this gives you a2, and that is equation 4. The next is, so the aim of this is to eliminate t so that we remain with only a1 and a2. So I'll multiply 2 throughout equation 2 and add it to equation 3. So when I do that, this is what I'm going to get. So in adding, this will cancel with this, and this minus this will give me 2g, this plus this will give me 5a2, and this is a1. So I've managed to eliminate t, and I only have a1 and a2 in equation 4 and equation 5. So next is to solve equation 4 and equation 5 simultaneously. So when I do that, I'll say that I'll multiply 5 throughout equation 4 and subtract equation 5 from it. So when I do that, this is what I'm going to come up with. So this negative 5g minus 2g will give me negative 7g. 5a2 minus 5a2 will give me 0. 15a1 minus a1 will give me 14a1. So I now have a1 as the only unknown. When I make a1 the subject, a1 will be negative 4.9 meters per second squared. Now negative means that it is moving in the direction opposite to the one we had given it. We shall see it at the end. So from equation 4 we shall say that we shall substitute for a1 and for g to remain with a2 as the only unknown. Therefore, when I simplify, a2 will be positive 4.9 meters per second squared. So now that I have a1 and a2, I can get the acceleration of the movable pulley. So acceleration of the movable pulley is a half of a2 plus a1. So when I add, I'll come up with, remember a2 is this and a1 is negative 4.9. So when I add, I'll come up with 0 meters per second squared. So that means that the movable pulley is not moving, it is stationary, and this one is moving in the direction we gave it, but this one is moving in the opposite direction we gave it. For example, this negative will come here and look at this diagram. In this diagram we had said that a2 is moving down the plane. Now because a2 is negative, it means that in actual sense it is moving up the plane. This one is moving down the plane because it was positive, and this one is stationary because it is 0. I think let's see how that is happening in this simulation. So this is actually the actual motions of the masses, whereby this one is moving up the plane, this one is stationary, and this one is moving down the plane. Now because it is not easy to realize that, that's why we use the concept of adding these two masses and comparing it with the movable pulley. So those are the accelerations. Next is to get the tension. So acceleration of the 1 kilogram mass, 2 kilogram mass, and movable pulley are 4.9 meters per second squared up the plane, and up the plane, then 4.9 meters per second squared vertically downwards, and 0 meters per second squared for the movable pulley. Now from equation 1 we shall realize that we shall substitute for a and remain with t as the only unknown. Then when I make t the subject, t will be equal to 9.8 newtons. So those are the accelerations and the tension which they wanted, and now let's see how mass can be awarded. So these two equations, equation 4 and equation 5, that is b1, then m1 for this addition, a1 for this acceleration of a1, this m1 for substitution here, and this for acceleration of a2. So this was supposed to be a2, and this a1 for the acceleration of the movable pulley, b1, m1 for substitution here, and a1 for tension. So I believe you have marked yourself and done corrections where necessary. So what I'm going to do, I'm going to leave you with another set of questions still on the topic of motion of connected particles involving inclined planes. that brings us to the end of this video. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video with the solutions has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.